Hey guys, this is lesson 3.5, the last lesson of this chapter, and it is the final lesson before the test. So I know this chapter zoomed by, but there's a bunch of just review that we've talked about. So I want to start off with the 5 different ways to represent an equation. So you can do ordered pairs, you can do a table, graph, equation, or mapping. So I want to just kind of give you an example of each of those. Okay, so here's an example of all those, and it's really not an equation, but like a relation. So just like these 2 ordered pairs, we could put them in a table, we could graph them. This is where the equation part comes in. It's more like a piecewise function, and then also the mapping. So we're going to ask ourselves, is a relation a function? So there's different ways to do this. You might think about like the vertical line test, which we'll talk about later, but yes, it is a function. Another way to look at it is that the x's don't go to more than one thing. Why or why not? So we talked about that. So vertical line test, we talked about like the mapping x can only go to one thing. Let's see, what else? Each input only has one output, which goes back to this. Just all sorts of things. Okay, so the domain, so this is a review. The domain is going to be your x values. So it's going to be 1 and 2. And then your range is going to be your y values. So it's going to be 2 to 5. Okay, so we're going to look at this and we're going to answer these 4 questions. Okay, so go ahead and try that and see what you can do. This should not be there, by the way. I don't know why. Oh, actually, yeah, let's keep it in. Sorry. I wanted to talk about the mapping there. Okay, so this is what I was talking about earlier with the mapping. So notice that there's 2 2s in the y, so that's okay. Each one of these guys is just going to one thing. Even though 2 of them, the 1 and the 3 are going to 2, that's okay. So it is a function because each input only has the one output. So that's what we want. If you have repeating numbers, so if we had like 2 1s here, that would be an issue. Okay, so go ahead and do the same thing here. Okay, so I filled this out. So this is what I was wanting to point out. These are the same, so like that doesn't really count. But like this 7 is going to a 7 and it's also going to a 1. So do you see how the 7's going into both places? So that makes it no, not a function. Also, like this is the domain and this is a range. Again, just a review from last time. So we're going to talk about the vertical line test next. So this is a review of algebra 2 or even algebra. So I'll take this example. So we have 2 5. We have 7 7. 2 5 again, so I'm not going to, and then 7 1. So if I drew a vertical line and everything was perfect, these would be right on top of each other. So this does not pass the vertical line test, therefore it is not a function. So what the vertical line test says that if you draw a vertical line at any point on a graph and it crosses more than one point, it is not a function. If it just crosses one point at any given time, it is a function. So like cases such as this is not a function, whereas this would be a function, because if I drew a vertical line at any point, it passes just one place, whereas here it does not. Okay, so we're going to apply that thought to this graph, so go ahead and answer that. So for this problem, it's pretty easy to see it's a function because it passes the vertical line test, but the domain and range are a little bit different. So I just wanted to kind of talk about that. So the domain is your x value. So where does it begin on your x values and where does it end on your x values? So right here, And again, I don't care about my y part of it. I just care about my x part of it. So it begins at -4, and it's an open dot there. So that's going to be parentheses. And then it ends at 5. Again, I don't care about my y value right now. And that's going to be a bracket because it's close dot. Now I'm going to do the range. And so I'm going to look at it this way. So from that perspective, how low does it go? How high does it go? So it goes down to -3, and that's going to be a bracket. And it goes up to right here, which is 4. And again, that's going to be a bracket. Okay, so the next part just needs to make sure that you can evaluate. So evaluate is just sticking in this number anywhere you see an X. So the only place that people make mistakes really at this point is that they just type it in their calculator wrong. So if you don't put parentheses around this section, you're going to get the wrong value. Okay, so I put my thought process out here. So this is kind of my second step. I just combine like terms. I ended up getting 29. Okay, so we are going from here on out to really focus about or talk about domain restrictions. And most of your problems will be including that. And everybody really tries to make it more than what it is. So you are really only looking for 2 things. You're looking for 0 in the denominator, and you're also looking for a negative number in a square root, or let's just say an even root. Those are the only 2 things that'll like mess up your problem. If you have 0 in the denominator, it's undefined. If you have a square root of a negative number, that gets into those i's, so that's not part of the real number group. So those 2 things are what we're going to be on the lookout for. So from there, it's super easy. So find the domain. So I'm going to say, okay, well, which one of these does this affect? Does it have a square root? No. Is it a fraction? Yes. So I'm going to look at that one. So I can't have this equal 0. So however you want to look at it, there's 2 different schools of thought. I always set it equal to 0 because I know that's what it can't be. So x equals 7. So I know that x cannot equal 7. Now, that's the way I do. A lot of people just start off with x minus 7 cannot equal 0. That kind of hurts my head. Bottom line, you're ending up right there. So here's another tricky part to this, is that any number will work on the number line except for 7. So like if I were to graph this, there would be a hole at 7, and it was going this direction, this direction. So we're going to need interval notation for that. So we have 2 kind of sections here. We have this section, which is negative infinity to 7. And that's going to be parentheses because I can't include 7. And then I'm going to say 7 to positive 50. So think about it as kind of like an OR problem. That's what's going to show up there. Okay, so same thing here. So hopefully you can see x, if I set this equal to 0, and I set this equal to 0, or not equal to 0, however you want to look at it. Basically, we're just doing like, so x cannot equal -8. And x cannot equal 9. So those are the 2 things. So this, that's not bad, but it does possess a difficulty in doing the interval notation. So there's an open dot here, but everything else will work. So there's kind of 3 sets. So let's do this one. So this is going to be negative infinity to -8. This part is going to be negative, oops, I want to draw infinities, -8 to 9. And then this part is going to be 9 to positive infinity. So once you get the hang of it, I don't think it's very bad, but it's just kind of weird at first. Okay, so what I want you to notice about both of these is that they deal with square roots. So we are going to set this so it can't be negative. So just what's under the square root, I don't care about all the stuff on the outside. What's underneath there has to be greater than or equal to 0. So it can't be a negative number. So if we have that, we're good to go. So let's see, 2x greater than or equal to 10. X is greater than or equal to 5. Okay, so that's pretty easy. If you need to graph it to get the interval notation, do it. So it's going to be, oops, bracket 5 to positive infinity. So it looks like that. Okay, so this one, same thing. I'm going to say 6 minus x has to be greater than or equal to 0. Just be careful with this one, because when we divide by -1, we have to flip the sign. So it's going to be x is less than 6, so or equal to. So it's going to look like that. So it's going to be negative infinity to 6 bracket. Okay, so this one has both things. So x can't be negative, and it can't be equal to 0. I'm going to say no negatives. So this whole thing, so this kind of poses a problem. So I encourage you to start off with like the square root, because that's what it is. And I'm going to say x plus 2, but instead of saying greater than or equal to 0, it can't equal 0. So I'm just going to say greater than 0. So x is greater than -2. So we have -2, open circle, they're going here. So notice that this is going to be parentheses. That's really the only thing it changes when you have both of those. Now, we have two different things going on in this problem. So this one, that one can't be equal to 0, and this one can't be negatives. I'd say no negatives again. So we kind of have to take this in two separate parts. So I'm going to say x plus 4 not equal 0, x not equal -4. So there's one piece to it. And the other piece up here, 3 minus x, has to be, and we're going to go back to greater than or equal to 0, because even though it's in a fraction, it's not in the denominator. So it still can be 0. So negative x is greater than or equal to -3. So x is less than or equal to 3. Those are our two parts. Okay, so if I were to graph this, everything works except for right where that -4 is. So I kind of have two parts again. So for this part, I have negative infinity to -4. And then for this part, I have -4 to 3. So two parts there. And we're done.